Hello and welcome to the SCAR 2020 data workshop entitled Sharing Science Data Fairly to Support Interdisciplinary Research Collaborations. This session is organized as a joint activity of the Standing Committee on Antarctic Data Management, SCADM, and the SUS Data Management Subcommittee, SUS-DMSC. And we would like to promote discussion around collaborations of researchers and data scientists in sharing data in findable, accessible, interoperable, and reusable way. Therefore, this session is announced as a workshop to promote more discussions. We will divide the session into two parts, and each part will be followed by a short panel discussion with the speakers as the panelists. We have also 3 posters submitted to this workshop, and I would like to encourage you to have a look at the e-poster exhibition space, where you can also comment on the posters. I will act as a convener of this session together with Frank Nitsche and Taco de Bruin. My name is Petra ten Hoopen, and I am Scientific Data Manager at the UK Polar Data Centre at the British Antarctic Survey, and also a co-chair of the SUS Data Management Subcommittee. Frank Nitsche is a research scientist at the Lamont Doherty Earth Observatory of Columbia University. He is a data manager at the US Antarctic Program Data Center and a member of SCADM. Taco de Bruin is a data manager at NIOS, the Royal Netherlands Institute for Sea Research. He is long-term member of SCAR and SUS data committees and currently a co-chair of the IODE Committee of IOC UNESCO. So the session will be recorded to be made available to registered participants in the past events section of the events platform. The organizers are also aiming to upload the recording to the SCAR YouTube channel. If anyone doesn't want their presentation to be made available on YouTube, they should reach out to the organizers by 12 August to opt out. We will use the Zoom platform, and questions can be asked using the chat box or the Q&A function in the Zoom. I would also like to ask you to please include in your questions the name of the person to whom the question is addressed. This will help us to follow on the answers during the session and also in our panel discussions. So this was to the introduction, and we will now move to the first part of the workshop focused on data tools. Our first speaker is Antonio Novellino from the EMODnet Physics, who will tell us about the SUS Map version 2 in his presentation entitled Getting Southern Ocean Data on a Map. Antonio, over to you.
Thank you so much. So I'm sharing the screen. Okay, can you see it? Can you see my presentation?
Yes.
Okay, perfect. So, hi everybody, it's Antonio Novellino. I'm representing EMODnet Physics. It's a very pleasure to be here and present on some update that we did on the SUS map. So, first of all, we are speaking about the SUS map. So, the SUS map is a tool to present data. But which data? We are speaking about the data from the SUS community and the SCAR community. So it is quite heterogeneous in terms of format, type, platforms that are recording this data. And so it's not that straightforward in order to present this data and make it easy and accessible to users. So we have to rethink a bit about how we present the data. And so that's why little by little we move it to this new version of the SUS map. Here you can see, the basic map viewer that we are presenting. That is, you can see that it's centered on the Antarctica area, and you have 2 main menus on the sides that we are now going to investigate a bit more in order to understand how it works. So now you are seeing a pre-recorded animation of the system, and we start from the menu on the left side that is presenting the background and layers, basic layers that you can find. Each layer is selectable, of course, and it is interactive, and it is presented together with some basic metadata. And one main feature is also that is presenting the source from which we harvested this information. And when it is possible, we are also citing the publication that are related to that specific data layers. Then, but the most important feature is the menu that we have on right part, because it is designed in order to let the user to interact in terms of platforms, so the vertical lines, or horizontally in terms of parameters. And when you click or you select one of the themes, then the system reacts by presenting some cards that are collection or products of the data that are available in the system. Now, let's see how it works in practice. And so we explore a bit of the in situ data. Here I'm selecting the recording from ships. Then I select one card that is the card about the CTD profiles. And the system reacts by presenting the latest CTDs in the area. For each CTD, then you can have some further features. So if you click on the CTD, then you get this basic metadata presentation. And then if you click on the open platform page, then you access to a web page that is presenting the data. So here we have a specific page that is designed to present CTD. So we are presenting profiles. But of course, if the platform is recording time series, you will see some different plots. And on the same level, you can also download this data. So you can select the parameter, the format, and then click and download the data. But we are speaking, for example, in case of the in situ data of a multiple dimension dataset. So if you want to explore a bit more on the time dimension, the dataset, the first action is to activate the card. Then you have a sort of calendar on top left of the page. And then if you play with that, and then you change the setting, for example, you include all the data from 2000 up to now, this is the result. So you can see that how easy it is to play with the system. And then if you select all the platforms and all times, then you get a picture like this. But we say that the source map is a tool for the community, and we try to make it as easy as possible, and the data should be one click away from the user. Another typology of the data is the gridded data. So it's also offering a feature in order to visualize and explore this multidimensional data set. In this case, we saw an animation of a gridded data that is the reanalysis of the sea temperature provided by iframe. It is the Cora product. And then you can play the animation. We saw some animation. Then if you click on a given position, the system reacts by extracting the time series for that specific point. But we say that it is a multidimensional dataset. So we also need to have a feature in order to explore in the depth this product. So if we play with the elevation of the dataset, then we change it, and then the system reacts by presenting the time series at that depth. And then, of course, it also update the picture that you see in the screen. But now I need to spend 2 words about the 2 main programs that are supporting the development of the source data portal. The first one is the European Marine Observation Data Network, and in particular, the 2 projects, a model in physics and a model in ingestion. And then we have the Southern Ocean Carbon Impact on Climate. That is a European H2020 project. One important thing is to say that we started the activity in collaboration with SUS and the DMC several years ago, and we started working together in order to unlock more data. And a model in physics also provided the preliminary version, the version 1 of the SUS map. Now, in Modern, we are in a phase in which we are moving towards decentralization. So all the portal will be, all the data set will be available from a single portal. And the community activities, the thematic portals, can focus on the data management of the data behind the portal. So in order to help and provide the SUS community a more advanced feature and web portal, we also invited Soshik to contribute. And so Soshik is in charge of the data presentation of the system. 2 words about how we get the data into the system. The architecture of the system is basically in 3 layers. We have a data layer, which is the machinery behind the system. It is a combination of tools implementing all the harvesting, the checking of the metadata, and it is done between by the activity of a modern physics and a modern gesture, but also with the community and the partners of these two programs. So we have the Copernicus Marine Service, the SeaDataNet National Geographic Data Centers, and other initiatives. Then we have a service layer that is organizing the data on top of open software tool to share and implement the FAIR principles. And this is especially developed by modern physics. And on top of this, we make available the data, so the map viewer that is powered by SOSHIC.
1 minute left, Antonio.
Yes. One important thing to say that is, I mean, the SUS map is not just a map viewer and is not just an integrator of data. It's more about the communities and the platform networks engagement. These are a couple of examples of activities that we did via a modern physics in order to engage, for example, the glider community or the fishing people in order to help and provide data. And we can see, for example, in the picture in the bottom, how complementary are these data for the users. So it's quite important to keep working on this. And if you are interested in data that are outside the SUS region, of course, you can find more on a modern physics. This was my last slide. So I would like to thank you very much for your attention. And of course, I'm available for any further question and details. Thank you very much. And I really invite you to play with the SUS map portal.
Thank you very much, Antonio. Very interesting presentation. Do we have any questions in Q&A or chat? I don't see any. Frank, can you confirm?
Yeah, no questions so far.
No questions so far. So I would have one, if I may, quick one. I was wondering, how can the scientific community help modern physics to build the SUS map? Would it, for example, have if people use open formats or if they use rich metadata? How could we help?
Yes, we say that it's quite important, the community engagement. So we need support from the people, and it's important to use common standards. I mean, the ones that have been developed for the past 20 years. And nowadays, it's also important to start adopting some common technologies that are facilitating the data interoperability. ERDAP is one very nice example. I mean, it was developed by NOAA. It is promoted by the GUS. We, within modern physics and SUS, were between the early adopter of this technology. And now we are also helping other providers in order to install this kind of system. So we developed some tools, for example, a Docker that helps the user to install the system. And we also support the, to configure the system in order to implement the data sharing also by using some common metadata standards, for example, the SeaDataNet vocabularies that are quite useful in order to let us to easily ingest this data and make them available into the SUS map, but also to serve this data towards other third-party users, because the community, you can never see how many people are interested in this data until you really make them available on tools like the ones that we were talking about.
Thank you very much. We might have a little bit more time to discuss in a panel discussion. But now we will have to move to our next speaker.
So it's very quick. We have there's no questions, but a comment from Petra that she congratulates you for the beautiful new interface. So,
oh, lovely, wonderful. Let's move to our next speaker, Griffith Kouser from the European Polar Board, who will talk about polar decks in his presentation called "Who is Going Where and How? What can they do there?" towards an integrated database for polar logistics and infrastructures, polar decks. Griffith, over to you.
Hi, everyone. Thanks so much. Let me share my screen and let me know if that works for everyone. Does everyone see that? Everything's okay? Great. Yeah, as said, my name is Griffith Kouser. I'm a policy officer at the European Polar Board. I'm presenting polar decks, and I saw Pip Britcher there in the chat, so I want to first of all say this is very much her project as well as Joseph Nolan, who recently was here. So I'm presenting on who's going where and how, what can they do when they get there towards an integrated database for polar logistics and infrastructure. And the first question in creating an integrated database for polar logistics infrastructure is to say exactly why do we need this? There's a lot of parallels between the presentation by Antonio and this one. This is going to focus on the logistical, the more physical infrastructure that's in the polar regions. And as anyone who's done field work there can say, the polar regions are very large. They're very remote, they're expensive to operate in, there's limited resources there. And on top of that, the data for what logistical infrastructure is there is often hard to access. It's not always readily advertised or put out. So the European Polar Board and its partners are working to fix that. The first iteration of that is the European Polar Infrastructure Catalog. It's a static document which had a list of various types of infrastructure information, as you see: stations, camps, laboratories, shelters, vessels, and aircraft. This was put together with EU PolarNet 1 and used data provided by Eurofleet's Interact, ComNap, and some other organizations. And that then morphed into the European Polar Infrastructure Database, which is an online tool. It's still on our website if you'd like to go look at it. That has all of the above information and is a searchable database. And later on, we began to host as well in 2021 the database of upcoming expeditions in the Southern Ocean, which is due south. That is a product of SOOS, Southern Ocean Observing System. And that has very useful information about expeditions happening in the Southern Ocean region. So we had both of these databases and we decided to put them together, and we came up with PolarDex. So there's PolarDex, that's the interface. It's a map-based interface with various filters, search functions for specific data. It also has some data overlays that you can put on there. And that was launched in April of this year. So we also have the Arctic, in case you're interested. I know this is mostly fans of Antarctic research, but we have both poles. You can rotate between the two of them. And if you were to click on one of those pins, you would get something a bit like this. There's the Concordia station in Antarctica. It gives you basic station information, the annual mean temperature, location, things like that. If you were to filter, for instance, by vessels, you might find the Esperides, a Spanish vessel operated by the Spanish Navy. It has basic information about the ship and the scientific instruments on the ship. And as noted before, due south, there's an example of some of their data on the platform. That's a logistics run, resupplying the Concordia station in Antarctica. So you can see the details about that. There's also an example on the right-hand side there of one of our data overlays. I believe that's the mean temperature for daytime sea ice in Antarctica. So all of this data comes from our partners. It is all hosted on PolarDex. PolarDex is a platform. We generally don't generate our own data, but we rely on our partners to put all of this logistical data together, and then we present it in one place. And that's to help improve efficiencies and to create opportunities for polar researchers so that they can see what is available for them to potentially take advantage of to help coordinate with other organizations. And so with that in mind, let's not switching over here. My apologies, I have a technical difficulty. Well, there we go. Okay. That in mind, I would invite everyone to go and look at PolarDex. You can find it at polardex.org. Go play around with it, go see what you like or what you find lacking and give us feedback. As Antonio said, user buy-in is very important for these platforms. If we don't have people actively using it and actively participating, the platform is not nearly as useful anymore. So we really do want to promote this as a tool that is effective to add value to polar research. And I have to thank all of our partners here listed on the slide: SUS, UPolarNet, CEOS Interact, ComNap, Eurofleets, British Antarctic Survey, Alfred Wegener Institute, Eurofar Aris, ISAFIC, and IATO. And I would like to also thank Blue Lobster, who are sort of the technical geniuses behind this, very good at putting our wonderful ideas into reality. So thanks again for listening. I appreciate the opportunity to be here. Petra, Frank, and Taco, thank you so much for the invitation, and I look forward to any questions you might have.
Thank you very much, Griffith. Do we have any questions from the audience? I don't see any at the moment. Then I would like to ask, how do you ensure information in Polardex is up to date?
The data is largely uploaded automatically. It's a feed into Polardex. So again, we rely largely on our partners, and we work with them to make sure that we're getting all the data we can. We're always looking for new data to integrate, but this mostly comes from partner databases. So it is up to date as much as any of the organizations are up to date.
Okay, so how much percentage-wise do you populate it from the automated feeds and how much from the manual curation?
This is a technical question, which I've only just begun recently, so I can't give you an exact number, but I can tell you it is the majority.
From the automated feeds?
That is automatic, yeah.
Oh, okay, thank you. Do we have a questions, Frank? Frank, would you like to read the questions?
Yeah, sure. There's one question came from Pip. How you're going to bring in new data sources to Polardex? Is there a mechanism for doing that?
My very simple response would be that we work with organizations to identify what data sets that they have that could be integrated onto the platform, and then our technical geniuses at Blue Lobster can put that in for us on our feeds.
Okay, another question that came in. Does Polardex include information on how to access infrastructure or only information about facilities that exist?
Yeah, that's a really good question, because we are trying to build out the capabilities of Polardex to help sort of coordinate people a bit more. Right now, it's mostly about what exists, as you said, but we are working to integrate sort of contact information. Due South is very good with its route planner and upcoming expeditions that will include, I believe, more methods of contacting the people who are actually working there and in charge of this to help people participate more and build more cross collaboration.
And another question is, are you receiving the data from ComNap, or what are the resources?
Yeah, ComNap is one of our good partners.
And one quick one. Is it possible to combine existing data of a certain area? I mean, can also data be integrated already exist, or can the system integrate already existing databases where there is biology, environmental data? I guess, maybe information that's in SUS map, for example.
I would say yes, because we already have data overlays on the platform. So it's really just a matter of getting more data overlays and ensuring that there's sort of the technical capacity to do that. But since we've already got several there, there's no reason why we couldn't.
Okay.
So.
Okay. Thank you very much, Griffith, one more time. And we will now have to move on to our next speaker, Julian Bodard from the University of Edinburgh, who will tell us more about BEDMAP 3, data standardization and fair publishing. Julian, the floor is yours.
Hi there. Can you hear me and see my slides? Can you hear me?
Yes, to both.
Yeah. Okay. Great. Thank you. Hi, everyone. So my name is Julian, and I'm a PhD student at the University of Edinburgh. And before a few months ago, I was employed at the Polar Data Center of the British Antarctic Survey to work on several projects, including BEDMAP 3. And this talk was prepared with Alice Fremont, who's a data manager at the PDC, as well as Peter Fretwell and Hamish Pritchard, who are also both at the British Antarctic Survey. And today I'm going to discuss a little bit about the data standardization and the fair publishing that we've been doing at the PDC for the BEDMAP 3 project. And we're very grateful for SCAR for funding the BEDMAP 3 project and supporting us over the years. So thank you for inviting us to give this presentation as well for this session. So just to give a quick sort of overview of what BEDMAP 3 is, in case you're not fully familiar with it. So BEDMAP 3 is a SCAR group with the aim to produce a new map and data sets of Antarctic ice thickness and bed topography. You can rewatch the introductory talk to what BEDMAP 3 is and sort of the more overarching aims of it on a more sort of data analysis science point of view from Peter Fretwell, who's also in the audience here. His abstract is number 397 of the SCAR meeting, so you can rewatch his presentation because this presentation is going to focus more on the data management side of things. And so as BEDMAP 1 and BEDMAP 2 were really significant in terms of community engagement, scientific discovery, and the use of the product for a wide range of scientific and policy applications when they came out. There is a slight difference between the time periods when they came in and where BEDMAP 3 is sitting right now in terms of data management. So BEDMAP 3 is really expected to have a similar impact as BEDMAP 1 and BEDMAP 2 versions, but it's really coming out of a time when making data fair or findable, accessible, interoperable, and reusable is an important requirement for many agencies, funders, scientists, and also most importantly for the general public. And so the BEDMAP 3 project is really the first time that data managers and scientists come together to work together on this project. The PIs, the data institutes that collected the data, that analyzed the data, that processed it, I think all realized that this data is really essential for many applications, such as modeling future sea level rise coming out of Antarctica in the next century, and that this data, must be made accessible for everyone to use. And so on the right-hand side here, you can see an early version of the BEDMAP 3 bed elevation grid, which was produced recently, a preliminary version of it. And so to give you a sense of scale of how much coverage and points we're talking about here, the total coverage for the whole BEDMAP project is 77 million data points from 270 campaigns that were acquired between 1960 and 2020 across Antarctica. And you can see the coverage here on the right-hand side, which shows the BEDMAP 1 coverage, BEDMAP 2, and BEDMAP 3. And then the bottom right figure shows the total BEDMAP coverage. That is the most updated one that will be included into the BEDMAP 3 product. And so the aims of BEDMAP 3 is to produce an updated grid of ice thickness and bed elevation as per BEDMAP 2. And you can check out the paper from Fretwell et al. in 2013. But also importantly is to standardize and release all the underlying data from BEDMAP 1, 2, and 3, following the FAIR data principles. And then lastly, all this data, the grid and the underlying data, point data, will be included into a data portal that we'll be discussing in a short while, which will interactively display and offer downloadable options for the data and the grids. So in terms of the standardization of the BEDMAP data, all the files that we receive from all the institutes around the world, that includes Russia, China, US, Europe, all these files have been converted to ensure consistency and long-term access to the data. We also provide extensive metadata within each CSV with variables complying with the Climate Forecast Convention and with recommended attributes from the Attribute Convention for Data Discovery, that's the ACDD. All the data that were submitted to us were checked before standardizations. That includes things like any data points that have latitudes that are greater than -60, for example, will be excluded because they're likely not in Antarctica and it's likely an outlier. Ice thickness values that don't match surface and bed elevation, or ice thickness values that are, say, greater than the deepest point over the Antarctic continent, plus or minus a certain amount, will be removed. That represents a very small amount of data points, but these values are checked, and all the missing values are converted to -999. And we try to establish conventions for file naming and variable naming, so that it offers a pathways for future geophysics data release in the future. And then finally, all CSV files are converted to point and light shape files for the gridding process, for the bed elevation and ice thickness gridding process. So for the shape points, what we did is essentially taking all the points that fall within a 500 by 500 meter cell, which is covering the whole Antarctic continent, and extract all the points along the radar track line that fall within a specific 500 by 500 meter cell, and extract key statistics, which I'll show in a minute. And all the bitmap data that will be published will be assigned a digital object identifier and deposited at the UK Polar Data Centre of the British Antarctic Survey using ISO compliant metadata. So to give you a sense of what the CSV will look like, we have about 1,700 CSV files that have been standardized, which are compatible with ISO standards, and we have made efforts to make the headers machine readable, but also human readable. And the total size of all the CSV files that we have is currently at 10 gigabytes of data.
1 minute left, Julian.
Yes, thank you. And you can see here some example of the CSV file for the Lake Ellsworth campaign over West Antarctica, which includes information about the campaign, the year, who to contact for that specific data, the institution, the funding that was received for this data, and then some information about the reference, DOI for the reference of the paper that discusses the data, where the data is deposited, if that is already the case, and then some information about the instrument, in this case, a ground penetrating radar, the processing that was applied to the data, and some information about the conversion of the ice thickness data into meters, which is useful for radar scientists and modelers. And then you can see a screenshot of one of the shapefile for one specific point over Antarctica, which includes statistics such as the mean thickness, median thickness, standard deviation, interquartile range, standard error, which are all used for the gridding of the bedmap product. And all these files will be made accessible onto this data portal that you can see on the right. This is an early view of the window. This is a portal that was created by Basite engineers in the Magic team, which is sort of based upon the ADD portal for data dissemination, if you're familiar with that. And this portal will contain data for bedmap 1, 2, and 3 as shape lines, also with the grids, and each file will contain links to the BAS Discovery metadata system where the data will be deposited, metadata will be viewable, and you will be able to download this data. So thank you very much for your attention. And yeah, if we have any questions, you can contact either myself or Elise. Peter is also in the chat here today. And we thank you very much for your attention and opportunity to speak today. Thank you.
Thank you very much, Julian, for your very interesting presentation. We have 1 minute for questions, if there are any from the audience.
No questions from the audience yet. I have one. Julian, once the bedmap 3 is live, there might be probably the initiative for the next bedmap 4. Are you planning to update the portal with the data as new data coming in, or will you do it only when you release the next version of it?
Yeah, so I think the idea would be to update the data portal and standardize new files coming in. We haven't decided on the timescale yet for this. I think the idea is to not wait the next 10 years for another bed map, but instead updating it every so often. We haven't decided on a timescale for this, but yes, the data portal will also be updated as we go along with the new data.
Okay, thank you very much, Julian.
Thank you.
Let's continue with the last speaker of the data tools part, Yiming Gan from the Royal Belgian Institute of Natural Sciences, who will present on a SCAR Antarctic Biodiversity Portal, GBIF hosted portal. Yiming, over to you.
Thank you very much, Petra. So let's see. Right, thank you everyone. So I hope everyone is doing well. I'm Yiming from the SCAR Antarctic Biodiversity Portal. I'm the data manager, and I'm very excited to talk to you about our portal, which is hosted by which is going to be hosted by GBIF. So who are we? We are the Antarctic node for GBIF and OBIS. So what this means is we help data provider to publish data in fair manner and compliant to the GBIF and OBIS data quality requirements to these two data repositories. So those who know this know that we have a number of portals, but here I'm going to present about these two portals that we currently have, the www.biodiversity.aq, which is powered by Wagtail, and the data portal is powered by Django. So these two are the custom portals that we made several years ago. And it involves a huge amount of coding, from harvesting data, parsing data to the databases, rendering the data, presenting the data, and styling the portal. It is considered amount of work. And what's more is having the portal is not the end, even if the funding ended. So why? Because the data standards evolved. There are new fields that are added. There are new data types that needs to be handled. We continuously have to work at the back to maintain the portal. And what's more, there are various software, hardware security updates that we have to do. So app maintenance is taxing. So as a data manager, I have to spend a huge amount of time in developing and maintaining apps, and this resulting in lack of capabilities from my end to provide support to the communities. And thankfully, GBIF started a hosted portal service not so long ago. So what is a hosted portal? So a hosted portal is a simple, branded, and fully customizable website that displays a targeted subset of GBIF mediated data to support participant nodes and their partners. As mentioned, we are the Antarctic node for GBIF, so we are qualified for this hosted portal program. So we applied for it, and we got it. The best thing about this is GBIF is doing all the heavy lifting at the back. That involves all the coding that provides all the features, and they even host the portal for us. And what we need to do is only to style the portal, to customize the features that we want, and to provide the content to it. So, which means this gives me more time to support communities by attending conferences, coordinating working groups, publishing and cleaning data, writing proposals, and also education and outreach. Here is the sneak peek of our hosted portal at the development site that I come up with within 1 week. So clicking the Start Exploring button brings you to the table of occurrence records. We scope this portal for all the occurrences within the meso polygon. There's the gallery tab that shows the images associated with occurrence records. Clicking on each images, we show you the detail of it. And there is also a map of all those occurrence records in Antarctic projection. You can also toggle for other projections to display the occurrence records. Then there's also the dataset tab that shows all the data sets that have occurrence records within the meso polygon. Right now, I'm doing a demo of searching for scientific names equals Electrona Antarctica for all the occurrences in this hosted portal. So this returned 13,000 results. So clicking on each occurrence records show you the details. You can also toggle the show all fields button at the bottom right to show you all the fields. You can see original value and the interpreted value by GBIF. You can also view the record on GBIF, which has a nicer interface where you view the interpreted value and the original values side by side. So back to the hosted portal. These are all the images associated with the occurrence record, which has scientific name equals Electrona Antarctica. This is the distribution of all this occurrence record aggregated. So one point can contain one result. You click on it and you can see all the details that you need. And because they're bin together in the point, one point can contain multiple results. For this point, it contains 1,000 results. And then there's a dataset tab that shows all the data sets, which has occurrences equals that has context occurrences that has scientific name equals Electrona Antarctica. As usual, you can view it on GBIF. When you view the data set on GBIF, it's no longer scoped within the meso polygon, but it shows the full data set on GBIF. So because it's already on GBIF's main website, so it's no longer the filtered version. And last but not least, you can download the data. With this, you need a GBIF account. For this, I'm not sure why, but it was not working yesterday yet. So I will have to investigate it. So we plan to roll this up at the end of 2022. And I would like to hear your feedback for the current state of this GBIF hosted portal for Antarctic Biodiversity portal, because I would like to know if the filters that I selected are usable for you. What is lacking? What can be improved? Any constructive criticisms are welcome. The survey will not take you more than 3 to 5 minutes. So this is the link to the hosted portal, the development site. And as usual, we put our codes in GitHub. You can open an issue if you find a bug or if you have any things that you would like to request there. And I would like to say a big thank you to the amazing folks in GBIF, Morton, Tim, Matthew, and Meliani. Without them, this is not possible. And I would also like to thank my supervisor, Anton van der Putte, who provided tremendous guidance in this. Last but not least, I would like to thank you for listening in and tuning into my presentation. Thank you very much.
Thank you very much, Yiming, for the inspiring presentation. I will definitely have a look at the portal later on.
Thank you.
Do we have any questions from the audience? Don't see.
So far, we only have some thank you for your presentation messages, and then the links that Anton provided that I also put in the chat.
Oh, thank you very much. I appreciate it.
Yiming, I would have one question. I was wondering if you are planning to host small-scale data sets that are supporting evidence for public publications, because they often are just, you know, small data sets, but to make these available is often quite a lot of work. So I was wondering if you have any strategy for that.
I'm not sure what small scale data sets means, but as long as they are biodiversity data and they can fit into the Darwin Core standard, which is the standard that GBIF and OVIS use, I believe that it is possible. Thank you for the question.
Would the scientists do the conversion, or would you do that for them?
It depends how complicated it is, I believe, because sometimes there are only certain things that we can do if it's an issue of lacking of data. So we have to go back to the scientists for it.
Okay, thank you.
Thank you very much.
If there are no other questions.
One question came in, like first as an additional answer, Anton put a link about how they support small data sets in the question. And then there was a question from Jan Robert Coder. Are you planning to host complex data like video continuous stream of accelerations and things on your portal?
That's a very interesting question. Thank you very much, Jan, for bringing that up. There are certain things that is not hosted by GBIF. For example, video is hosted somewhere, but you can put the link that associated with the occurrences into the file that can be published to GBIF. So hosting and linking are two different things, I'd say. So I'm not entirely sure about the continuous streams of acceleration, but as long as it is something that can be accommodated by the Darwin Core standard and can be linked to, it's a possibility that can be explored.
Thank you.
Thank you.
I would just like to remind everyone that we have also 2 data tools posters. One is from Masayoshi Kozai on development of the AMIDER system, a database application for open science, and another one from Elizabeth Rudolph on a geospatial database for the subantarctic Prince Edward Islands. So please see the exhibition space for details. We will now move on to a short panel discussion. We have about 8 minutes for that. And all speakers and poster presenters of this workshop should be assigned a role panelist. So I would like now to invite all panelists to join a short panel discussion around data tools. First, we would of course try to address remaining questions, but I believe we have answered all questions so far.
We do have, I think Anton has his hand up, so I can, maybe he wants to say something, so I can give him permission to talk. Anton, if you want to say something.
Yes, so to the questions from Jan and for the data, small data sets. So I think in general, what we tend to do is we try to educate people on how to publish themselves. But for some data sets, we can find more time to do it. I think the key there is that it's good to have a fairly clean data set, and then conversion is quite easy. We will have a workshop for that next week as well. I believe on the 8th, but I have to check that again. And for publishing, we tend to use Zenodo for that. That's a free repository for data types, and as Ming said, we then link to those data types, but still use the Darwin Core format, so all of that data becomes discoverable in that way.
Okay, thank you for the clarification. I have a first question for the discussion to the panelists. What technologies exist or are on the horizon that might improve fair data sharing? What does it come to mind for you? If you would like to comment.
I can say something very briefly. I don't have specifics. I would love to actually throw this question to Anton, because I think one of the biggest issues that a lot of us face, GBIF was very interesting in terms of its data standardization. But I think that's something that all of these portals, all of these platforms face, is getting metadata standards to be adopted across all the various organizations we work with to make sure that we can put everything together in a comparable format. But I would love to hear Anton's comments on that.
Well, I think equally we can throw that back to Pip or Taco. I think one of the key developments there is trying to work on, we have a working group called Polder, which includes people from the Antarctic and Arctic, and that's sort of looking at what is viable options there. And technically speaking, there's a metadata standard that's used by Google, which makes it broadly used and more interesting, which is schema.org. So currently, as data manager, we're sort of thinking about using that standard to try and link these different metadata standards, but at least to make data sets more discoverable. And actually, for any data which is published in GBIF and in OBIS, these data sets get these schema.org data standards translated directly. So it's a very efficient way for us to do it. So schema.org is sort of a small attachment to any sort of website with information on the data that's on that website. And so it's, I think that's the most promising tool that we have at the moment. But Taco and Pip can comment on that as well, or Frank as well, or Petra.
We also have a presentation on Polder coming in the second part of this workshop. So perhaps we can also follow up after that. So what I'm hearing, it seems that data standardization is one of the bottlenecks for sharing data fairly. So it doesn't seem to be a time or money, it's rather the culture. Is that right? So that scientists help to get the data into the portals by adhering to the standards, existing one and developing one. And in that way, we can get more data into the community. Is there anything else? What are other bigger other bottlenecks? Are there any other that we could identify?
Yeah, if I can add something, I don't think it's just data standardization. I think it's also the time allocated to and funding allocated to scientists for doing that, for being engaged with the process. I don't think there is enough appreciation for the time involved in doing it for a scientist to work with a data manager. There is no sort of, that is not taken into account for career development or for grant funding or for anything like this. So I think there is effort to be done in that sense for scientists to be engaged with it and being able to dedicate that time, not out of hours. I think that's a big part of it. Data managers are paid for doing data management, but they can't work without the scientists themselves. And if the scientist doesn't have the time funded for that part of their job, then they might struggle to find the time to do that. And that might be where there is a bottleneck or leakage for data science in general, I think.
Thank you for the contribution, Julian. Any other thoughts? Yiming, you have your hand up.
Yes, I absolutely agree with what Julian said. I also think that the funding scheme encouraging a lot on innovation, building something new, but not so much on maintaining the existing infrastructure. So I see a lot of people nodding. and yes, that's one of my thoughts. I'm not sure what we can do for that, but I feel that a lot of people could resonate with that.
Definitely. I'm looking at time. I think we will have to move on to our next part of the workshop, which is focusing on data sharing. And our first speaker for this session is Matt Nugent from the Madison Area Technical College and University of Wisconsin-Madison, who will present his talk on the Antarctic Meteorological Research and Data Center. Matt, over to you.
Thank you, Petra. Hello, everyone. Let me just share my screen here so I can get this up for you all. All right, we'll just go with it like that. I hope you all can see that there. So my name is Matthew Nugent. I'm a staff member at Madison College and the archivist for the Antarctic Meteorological Research and Data Center. This presentation hopefully acts as sort of a soft launch for the AMRDC, which we've been developing for the last year and a half now. So I just wanted to give a quick overview of our work, how we're striving to transform our archival data holdings to meet FAIR standards. We're a successor organization to the Antarctic Meteorological Research Center with no data. Although we were data focused, we stewarded Antarctic meteorological data for decades at University of Wisconsin-Madison. The idea behind our switch to the AMRDC is to modernize our data management system, while also making it similar to library or data management systems that you're probably all familiar with. Clean web interface, various search tools. So we can also have a place for external researchers to deposit their data for long-term holdings. So there's a glimpse of what it looks like and a link if anyone wants to check it out. We currently have about 4 decades worth of automatic weather system data, as well as a handful of data sets from external researchers already in the database. Data held in our repository has already been cited, even though we're just launching right now. And uses our new metadata schema, familiar web portal, hopefully, but our repository is also accessible via API. So full data research and retrieval. Here's an example of what the same record looks like side by side. That's JSON on the right, so that you can bring that in programmatically and create larger collections. Subsets of our collections, hopefully. And we're also making end-to-end user metrics available, statistics on downloads, when your data has been seen, who's seeing it, and when it's been cited, hopefully, as well. We're also working on some proprietary tools to kind of fill this out a little bit and help with model discovery. Mapping, visualizations. We have a database that can sort of give you custom slices of data, all at user request. Finally, there's another example of our data visualization tool that hasn't launched yet, but hopefully very soon. We are also working with SCAR's Ant Climb Now project. We were funded to bring even more data into our system, hopefully stuff that's sort of fallen through the cracks in Antarctic research, smaller data sets from lesser known organizations that we can signal boost by linking to alongside our like-minded data holdings. We're still very active in data collection. Here's a kind of an overview of our ongoing projects and some future projects as well. We're interested in everything from plain text observational data to satellite composite animations, everything in between. Our real-time data services are, oh, here's some examples, samples of some of our holdings. Those are the composites there on the left and some AWS data, bottom right. We also have a number of real-time data services that we're still making available to the community. We're hopefully expanding access on these and kind of bringing them, modernizing them a little bit. Aside from our data repository, we have data available through Threads, Makaitis ADDE, and LDM, Antarctic IDD as well. Going on 2 decades of existence there. There's an example of our Threads. Threads is going to be used to move larger data sets around. A repository is more geared towards smaller text files, images, and stuff like that. So with our gigabytes of satellite composites, Threads is going to link up with the repository, extract metadata, and just hopefully move that data around a little bit quicker for our audience. Data sharing with Antarctic IDD. This project is going on 2 decades of existence, and we're working on ways to formalize and streamline this network as an end node to a number of data producers. And you can kind of see the complicated network that we've built in this image. Have a couple of use cases. This was generated by one of our students who works with us. It's a Marble Point climatology, which is one of our most popular data sets. Yeah, this is pulled straight out of our repository and cited in research. They just really had to get the data and crunch the numbers, right? We do everything else, hopefully. Likewise, here's an example of some of the stuff we're doing with the Black Island Wind event, which took place in 2020. And we have a larger scale study using these data points that we're working on as well.
1 minute left, Matt.
Thank you. So to reiterate, we have an extensive archive of data. The data repository is for the community. We're excited to work with new organizations, early career scientists, established groups, everything and everyone in between. And as an NSF funded project, we're now on their official list of disciplinary repositories, and we're working to build our reputation in the community as a primary hub for Antarctic meteorological research. We used to provide this data via FTP site that's going away. So we hope this transition is easy for everyone. And that means listening to the community, and we're excited to do just that. There's some contact information. Yeah, that's all I've got. Thank you very much.
Thank you very much, Matt. Do we have any questions from the audience?
No questions yet come in.
Then maybe I can have one quick one. What is the most challenging task for the repository at the moment?
That's a great question. For us, it's been quantizing the data, chunking it up in a way that makes sense for the community. We are funded to quality control the AWS data. And it's a regular occurrence that we go back 20 years and do like 5 years of QC. So we want to make individual files as exposed as possible. And that means doing things by year, by station. And that's just impractical for folks who want a large amount of data. So yeah, I would say moving and packaging data is the most intense part of this. So we're hopefully going to have a database, SQL database that's publicly accessible, which is an image of the repository that will mitigate that issue.
Okay, thank you for your view on that. If there are no other questions.
There was one just coming in by Petra, can we get the metadata reserved in SUSE map alongside other data type?
I'm sorry, I'm not familiar with SUSE map. Is that
That's the portal that Antonio was.
of course, yes. That would be interesting. Absolutely, we would definitely be interested in talking about that. I'm just the archivist. I'm not the scientist. Our project investigator, Matthew Lazara, would be able to speak to that. But we're definitely interested in those kinds of collaborations. Absolutely.
Yeah, and according to the SUSE map backend infrastructure, as soon as you publish the thread server and you publish layers on top of the thread server, we can consume directly from there. So it's straightforward.
Excellent, excellent. Yeah, that's the kind of integration that we're looking for. So that's fantastic. We'd like to talk more about that. Absolutely.
We keep in touch.
Excellent.
Wonderful, wonderful. New collaboration on the horizon. We'll have to move to our next speaker now. Thank you again, Matt, for your presentation.
Thank you.
And our next speaker is Karen Payne from the WDS International Technology Office, who will present on data discovery and mobilization through Boulder's Polar Federated Search. Karen, the floor is yours.
Thank you. I appreciate that. Yes, my name is Karen Payne, and I'm presenting here on behalf of my colleague, Chantal Berhay, who couldn't be with us today. So I will apologize in advance if I say anything that's sort of nonsensical, it doesn't make sense. You can blame me, but certainly not me or the co-authors of this presentation, Taco and Amos. So what I want to talk to you about today, and I appreciate Anton gave us a bit of a intro to what we wanted to talk about, is this work that we've been doing to explore the use of schema.org in a data discovery environment. Schema.org is a collaboration. It's a lightweight vocabulary that was created by the big search engines, Bing, Yandex, Yahoo, and Google. The idea is that this vocabulary could be used to structure websites and allow the content of those websites to be structured, accessible, and then parsable by machines or applications. And so we wanted to look at, there's been a lot of interest in the data management community about the application of schema.org to data management. At a minimum, one of the big drivers of this is Google dataset search. So if you have this schema.org markup on your metadata, then you are eligible to be included in Google dataset search portal, which is, the idea is that it would do for data sets what Google Scholar did for publications. If you look at a graph of sort of discovery of publications after Google Scholar went live, it exponentially off the charts. And so that's one of the reasons, that's one of the drivers why people are interested in this. And so here's a quick example of what that might look like. This is a JSON LD in an HTML page, and it just shows the context, which is the location where the terms are located, and then the suite of terms and their values. And so in order to do this, we had a number of different collaborations and a number of different organizations that we're trying to work collaboratively with. One of the first ones was the Research Metadata Schemas Working Group at the Research Data Alliance. This group compiled a list of crosswalks from 15 very common metadata standards that are already in use by the scientific community, and then crosswalking those properties to terms in schema.org. And we also created a set of friendly visualizations of those crosswalks. And then the other output from this working group was a set of guidelines for publishing structured metadata on the web. And so for example, if you're using ISO 19115 and there's a suite of terms from that metadata standard, and how data managers are currently have decided their equivalent terms are in schema.org. And so, like I said, you can go here to this friendly sort of visualization of those crosswalks. You can do searches and you can see how other people are using those terms. And so one of the other groups that we've been pleased to work with is the Polder collaboration between SEUS and the Arctic Data Committee and the Standing Committee on Arctic Data Management. Again, this has been ongoing work for a number of years that are looking at best practices for using science-on-schema.org and by harnessing the science-on-schema.org guidelines. So science-on-schema.org, I'll talk about in just a second, and to see if Polder can use those guidelines or create their own best practices, which they're doing, and then to set up a federated search portal, a single location where users can come in and search for metadata from a suite of data repositories that are in the Federation. Those data repositories have adopted some version of schema.org. And so this builds very much on top of the years of work that has been done by ESIP, Science on Schema.org cluster, or SOSO. And they have a very good set of recommendations about that for marking up metadata for the earth sciences. And that cluster is ongoing and meets regularly. And the way that we tend to think about it is that there's a schema.org, which is the core ontology. SOSO, or Science on Schema.org, is a subset of schema.org. And then Polder is an even more smaller, refined set of the SOSO ontologies that are used particularly for the polar community. And so the primary difference between SOSO and Polder is that SOSO is designed for the environmental sciences with great documentation. They generally let the data repositories decide what the most appropriate terms to use are, whereas Polder is being a little bit more prescriptive, and they are deciding what is mandatory, recommended, or optional terms specifically for the polar community. And so the Polder has decided that there is about, I think there's 11 or 12 mandatory terms that should be used in order to be included in this federation. So there's a suite of benefits in this. If there's, again, the idea is to help overcome the existing metadata standards, different metadata standards, and to help with the interoperability and discoverability within a single search pool. The worst case scenario is that even if this initiative goes away, Google Dataset Search only requires 2 terms, a title and an abstract, to be included in Google Dataset Search. So once you do schema.org markup, you're eligible to be included in the Google Dataset Search. Right now, the Federated Search has these 10 repositories with a Canadian consortium representing a suite of other data repositories that will be coming online soon. And for those of you who are interested in the back end, it's a very, very lightweight, very deployable, portable. We designed it to be very portable. It's a Kubernetes deployment that has a triple store. Most of our development work has been working on the open source Gleaner tool. The Gleaner tool looks at a sitemap. It goes out to the sites. It parses all of the structured data there and then helps create an index for it. And then that index is searchable in the Federated Search app.
1 minute, Karen.
Okay, we launched in March at the Arctic Observing Summits. We have a Jamboard for feedback. It's very, it's not nearly as impressive as these other tools that have been shown in terms of a portal. And I think that's an open question about whether or not we should continue to develop the interface, or whether we should be more supportive on the back end, providing tools and development for that. If you do want to be a part of the Federation, if you're already being indexed by Data One, you're good to go. If you want to mark up your metadata and then give us your sitemap, we can index you. And if you need support, contact our team and we'll be happy to help you get started and help you with your markup. Long-term sustainability, if you want to know more, there's regular hackathons, and you can contact either Melinda or Chantel, and they're going to tell me how badly I did this later on. So I think that's about it. Thank you very much.
Thank you very much, Karen. Do we have any questions from the audience?
Not yet.
Not yet. Do we have time for one quick one, Taco? Maybe I just wanted to ask your personal view. Which way do you think should we go? Building the front end or the back end?
You know, it's. I mean, I really am somebody who doesn't want to replicate work, and I see so many great-looking portals out there that I really want to support the existing initiatives that are done. And I think that you know, Chantel is a tremendous community builder. She's great working, helping develop guidance. Melinda's a great developer. And so I do think that maybe our role could be more of a support, but we work under an advisory group that's going to make that decision. So the advisory group is going to decide whether or not we continue to develop the portal. And in fact, just last week on the development side, Melinda put in a couple maps, polar projection maps for both Arctic and Antarctic to allow for map-based search. So we're certainly open to developing it if that's what the community wants. And I think that's not for me to decide. Yeah.
Thank you for your view anyway.
Yeah, thanks.
Let's move to our next speaker now. Emmanuel Pica from the National Institute of Geophysics and Volcanology to present about sharing ionospheric data in polar areas. Emmanuel, over to you.
Yeah. Hello, everyone. Can you hear me and see my screen?
Yes, we can. Thank you.
Okay, thank you. So Emmanuel Pica from National Institute of Geophysics and Volcanology, INGV. I'm working with the Upper Atmosphere Physics Research Group. Today, I will briefly talk about sharing ionospheric data in polar areas. So just a bit of scientific context. INGV is performing ionospheric observing in polar region as well as in other locations around the world. Ionosphere is the upper layer of the atmosphere, and the poles are a natural laboratory for monitoring and conduct fundamental research on this kind of scientific field that is also called as space weather. So basically, since 2003, we are managing in collaboration with other institutions permanent observatory in the Arctic, so in Svalbard and in Greenland more recently, and as well as from Antarctica, so the Mario Station, Italian Mario Station, and the French Italy Concordia Station, as well as collaboration at SANEFOR managed by the South African Space Agency. So basically we have a permanent observatory that are producing data in near real time every day continuously, and the management of this data it's quite complex, especially because we are trying to build some services with this real-time data. For example, we are collaborating with the Pegasus Consortium that is providing advisories for space weather to the International Civil Aviation Organization. So we developed a data management system at INGV. I will describe it very, very quickly. On the left, we have the station that are sending this data in near real time. Then we have the space weather information technology system that collects, harmonizes this data and collect them inside a database. And then we have a RESTful web service that allows us to provide this data to the scientific community through our website, that is the eswa.ingv.it, and to build also several top application like visualization or analysis tool. So lately we are distributing this data under Creative Commons attribution. So these data are open basically, and we attribute also a DOI to this ionospheric scintillation data collection that involves also the data coming from the polar region. This is just some tools that you have on the website, but what I want to talk today more is about our experience and some difficulties that we are facing. So for example, we lately had this maturity self-assessment based on the Research Data Alliance data maturity model, that it's a very, very good tool to assess the fairness of your data. So of course, we have to consider, as is written here, that FAIR principles are inspiring concepts, but not strict rules. At the same time, of course, to remedy the proliferation of different kind of metrics to assess the fairness of the data, the Research Data Alliance developed this kind of common set of core assessment. So in the bottom left, you can see the result of this assessment on our data. And I have to say that for us, it was a great tool to understand what was still missing. Of course, it cannot, it will not tell you how what to do to reach the fairness, but it cannot tell you what you can do, or what you miss, what you are missing in your system. So just few things. For example, our DOI is currently associated with the world data collection stored in database. Basically, we have an open database that you can query through the web service in different way. And it's not a trivial problem understand how to address specific persistent identifier to single subset of data. Moreover, from the point of view of interoperability and reusability, we lack of ontologies and controlled vocabularies at a community level. So especially for the upper atmosphere physics. Moreover, we don't have any standard of our web service is not compliant to any specific standard, and also we should improve discoverability by implementing, for example, schema.org, as we were hearing now, also, for example, in the polder infrastructure. Moreover, our system is it's an increasing system. We are also accepting data from other infrastructure, but it's still a small, a very specific research field. So we are also contributing in other projects with our data as data provider, let's say. For example, I reported here 2 projects. On the left, the Italian Antarctic Data Center, and on the right, the PTA project, that are 2 different kind of projects for the approach that they have towards fairness and towards share the data. The Italian Antarctic Data Center, it's a project started 3 years ago, and now we have a website. Here there is the link that is providing a metadata catalog to discover all the data provided by Italian research institution in the framework of the Italian research in the Antarctic region. And of course, it's oriented to the Antarctic community, and it's a multidisciplinary platform. From a technical point of view, in this project, we adopt ISO 19150 metadata model, and also we harmonize the information, the metadata through by adopting global change master directory keyword. On the contrary, the PTA project, it's an ongoing project in the framework of Horizon 2020. It's a big effort at European level to bring together all the knowledge of the research facility involved in the upper atmospheric research. So it's very, very field specific platform. And also the methodology was different. So we are implementing metadata model based on the ISO 19156, that it's the standard for observation and measurements. And we are, very importantly, developing a domain ontology strictly tailored for specifics, that it's helping us a lot to reach more fairness. But just to point out something and to conclude my talk is that for sure these projects are very, very important also for the from a financial point of view to help us to improve the fairness. But anyway, let's say proliferation of this kind of initiative and data sharing in portal requires even more effort and attention toward the realization of a fair ecosystem from a point of view of the data provider, and especially to avoid to duplicate data and information. And
1 minute left, Emmanuel.
Yeah, I was quicker than that because I just finished. So thank you. If you have any question, I would be glad to answer.
Thank you very much, Emmanuel. Do we have any questions from the audience? I don't see any at the moment.
No, no questions come in yet.
I really like your self-assessment. I know it's challenging because we have tried to do something similar in our data center, but it's also, you know, helpful for the development. I have seen that you have mentioned the collaboration with other institutions. Maybe I have just missed it. What other institutions do you have data from? I believe it's not just the national Italian data. Is that right?
No, yeah, it's not just Italian. It's I can show you. Basically, in the polar region, we have a collaboration with the South African Space Agency. But at the Italian level, we are working in the framework of the National Research Project for Antarctica. And so the ENEA, as well as the National Research Council for the Arctic, that of course are providing us all the help for the logistic mostly, because our institution is not managing directly all the observatory, but we are relying on the ENEA and CNR, for example. And also we have data from all over the world from other institutions that are providing. They don't have developed a system to manage in real time this data, but in some cases they have this instrument founded by a project, and they send us their data to take advantage of what we developed. And this is very, very important for us, of course, but brings our system to another level from the point of view of the data management that it's not easy at all. A problem, for example, is how to address the DOI that we already established for our proprietary data with the data that is proprietary by other institutions. So there are several problems on this topic, for example.
Thank you very much for the clarification. We will have to move to our next speaker now, Daniela Acetella from the National Institute of Oceanography and Applied Geophysics, who will talk about Isobata bathymetric data acquired during research vessel Laura Bassi Southern Ocean transits. And I believe this is a pre-recorded presentation, so if we could please have the recording now.
Good morning, everybody. I'm Daniela Acetella from OGS, Italian National Institute of Oceanography and Applied Geophysics. I work in the vessel department responsible for the icebreaker Laura Bassi management. I have a long experience as onboard surveyor and multi-beam data processing. Working at OGS, I learned in the year how important are also low resolution bathymetric data shared at international level for scientific study in Antarctic waters. I want to share with you Isobata onboard experience. So we'll talk about project aim, survey plan, partnership, equipment, but also acquired data that show the importance of data acquisition during transits. Isobata aims. OGS bought icebreaker Laura Bassi in 2019, and first Antarctic survey transit took 29 days. So it was very important to exploit transit for scientific data acquisition. Keeping in mind the CBAN 2030, OGS and his partner applied for an Antarctic research call with Isobata. Primary aims of the project are to ensure bathymetric data acquisition during transit in the Southern Ocean and to foster onboard underway data acquisition, collaboration, and data sharing during transit. Another point is to foster international coordinated effort between vessels operating in raw sea to maximize bathymetric data acquisition. The project was approved in June 2021, funded in 22. It's a 2 years pilot project, and the acquisition are mainly bathymetric and performed also during logistic leg. Isobata obtained 5 days as vessel speed reduction and rerouting during transits. Survey plan. Acquisition are planned along preferred corridors in white on the image on the left, part of which cover Macquarie and Emerald case study area in black on the image. And we plan to cover 4 parallel track lines in this area in 2 years. Corridors are based on a study of Italian vessel track lines in Southern Ocean plus IBSCO coverage. Isobata partnership. Leader partner is OGS that has a long experience in acquisition in polar environments and in developing ET solution for geophysical data sharing like seismic data library. So he's in charge for Isobata data acquisition and for the development of the data storage repository. Milano Bicocca University is in charge for processing, interpretation and classification of geomorphic features and for developing an automated procedure for submarine landform classification. IGAG CNR of Italy is in charge for geodynamic study of the 2 case study areas. Equipment. Isobata benefits the opportunity to use the new Kongsberg acoustic instrument installed on the Laura Bassi during the 2021 refitting, plus Filippo Muccini magnetometer and Partenope University XPT system, and used also XPT SCTD acquired in the frame of ROSI and Collapse project. Survey started 4 December and ended 25 March. Isobata team was on board all the time and shared knowledge and data with all the scientific people on board. Before the survey, we prepared our acquisition plan and procedure, but during the survey, things were a bit different, and we noticed a lot of the interferences between acoustic instruments, so we gave priority to multi-beam acquisition plus 150 kHz ADCP. Navigation between eyes made impossible the use of sound velocity pole, so finally we used the sound velocity calculated from the thermosalinographer. And the multi-beam eyes window comported a signal strength reduction of 20%, so at 4,000 meter depth, what was one time depth. And this comported also a vessel speed reduction to 9 knots in the Southern Ocean and corridors reduction. And in the Ross Sea, data and SWOT were very good, and speed reduction was only 10%. In the Ross Sea, we had the opportunity to acquire lots of bathymetric data during transit, and Isobata acquired data during the first logistic and second leg were very useful during the third geophysical leg, and comported time saving in case of project like Greta, Disgeli and Collapse. We had the opportunity to acquire also data in the Italian mooring site, and on the right you can recognize on mooring G area some iceberg scar, and some scar has an elliptical shade due to tide. So seafloor contains also current information, not only. In point G1, we acquire a SWOT along Isobata corridor where Canducci during the Ross Krill survey detected some gas flare. In the Southern Ocean, due to the strong vessel speed reduction necessary to acquire bathymetric data, we focus on some area. For sure, we acquire data in our case study area, Emerald and Macquarie, but we acquire also some opportunistic data for New Zealand in Vanille area, and we acquired also magnetometer data in our case study area. And if we focus our attention in Emerald area in orange and we do a profile on acquired data, we see a difference in depth between IBSCO profile and Isobata, that is 1,200 meter. And if we plot all grid data in same color scale, we see that lower solution bathymetric data can mask very important tectonic features. In Southern Ocean, we acquired also a SWOT along the old OGS Explorer dataset in Macquarie area. In the Southern Ocean, in green area, we mapped a very interesting features in a totally unknown area. Difference between IBSCO and Zobata is 600 meters. Very close, we acquired also bathymetric data for collapse project, the scientists embraced Zobata vision, and we acquired data complementary to existing data sets. In conclusion, Isobata detects new features in the Southern Ocean, enhanced onboard collaboration, and Isobata real-time data sharing comported a significant time saving for geophysical projects like Nitsche, Greta, and Collapse. Isobata strengthens Italian-New Zealand collaboration, and an important desiderata for Isobata would be to have a coverage upgrade in real time. Thank you everybody for your attention.
Thank you very much, Daniela.
Yeah.
We have you in the audience. Would you
Yeah,
like to
yeah,
add
but
anything?
my internet connection is bad, but also the audio in my presentation was bad. So sorry, excuse me for this. So the concept is that, well, for my project, I need shared data. I need data in real time because I need to know coverage, and if possible, I need also XBT from other vessels. For coordination in this kind of work, it's very important to share data in real time. After the work, yes, we have to share data. People need data for study, but also during acquisition is important to share data. This is a key point for me. So if you have any question.
Do we have any questions?
There's one question in the chat from Paula Jana. Do you get any thermal plume signatures, for example, from CTD data in the hydrothermal vents located in the northwestern part of the Ross Sea? Specifically, the study locations of the collapse.
No, in collapse project, no, but we see flare very close to Cape Adare. And there was the slide, more than me, there was a project, Ross Krill project from Yole Nori on board. We were in acoustic silence on board because they were acquiring EK80 multi-featuring echo sounder, and they saw lots of flares. After, when we were back, I acquired a multi-beam line, but didn't show anything. In any case, this line is along Isobata corridors. After 2 weeks, there was 200 kilometers in distance, there was a very big earthquake. So it was quite interesting also this. If someone was it could be possible to do something like a gas plume monitoring along the corridor also. In any case, when we acquire multi-beam data, sometimes we cannot reduce the speed for logistic purposes. So it would be interesting acquire also EK80 data or Topaz data. So it's the data acquisition during transit can have a very big, it could be very interesting from the scientific point of view.
Thank you very much, Daniela, for your answer. We will now have to move to our next speaker, Frank Nitsche from the Columbia University, to tell us about handling diverse long-tail Antarctic domain data at the US Antarctic Program Data Center. Frank, the floor is yours.
Okay, I guess you can see my screen. Good, so thanks to Petra. So I'm going to talk about handling diverse long-term data at the US Antarctic Program Data Center. And there's a little background. So we are funded by the National Science Foundation in the US, and we are the main domain repository for US Antarctic data in the US. And you can check our website here, www.userpdc.org. So if I'm talking about like long tail data, what I mean is basically that we can distinguish two different data types. There's one like more homogeneous discipline specific data, for example, like the weather station data we heard about earlier, but also maybe like seismology data, maybe like long-term observations of oceanographic data, routine-based data from ships, etc., that are very more or less routine measurements with very good standards from the community that's provided. But then there's a lot of other data that from individual research projects, mostly, that are very unique. All of these data are often like a one-of-a-kind data sets that can be, so they're very diverse, and there often is not a specific repository for those. So for most of the homogeneous discipline-specific data, say we in the US have discipline-specific repositories like the Antarctic Meteorological Research Data Center, for example, or UNAFCO or BICO-DEMO. On the other hand, there were not, there's all the other data that need another repository. So a lot of those data are now coming to the USERPDC data repository. And just on a side note, we also actually developed a project catalog where we, for each individual awards, or basically create like links and have some very basic metadata for the different data sets in different repositories. But today I'm going to mostly talk about like how we're handling data that are coming directly to us. We try to make it easy for people to deposit the data. So we have direct link from our homepage to deposit data, and this will get you to a web form where we ask for basic metadata, like title, description, who are the creators of the data, what are keywords associated with the data, what's the spatial extent, temporal extent. And these are very like standard metadata that also then used, for example, in schema.org. In addition, we try to capture as much information about the data sets as well, which is then often not so much prescribed, but we have like text forms where we ask for details of instrumentation and devices, how the data were acquired, what procedures were used, how the data were processed, and maybe description of the actual data content of that are delivered. And then in the end, we also ask what kind of license the people would use. We offer like several options. One would be like Creative Commons attribution that has just with attribution, but other options would be like a toll-free Creative Commons license as well. Once we have this data, we have data curators who check the data and ask potentially, go back and forth with the data providers if there's any questions, and then we make this data available on a data landing page and in our portal. So we have again the title, we create a DOI, potential link to the Antarctic meta directory, and then we have listed as a basic metadata here. And we also have links to overarching like projects and awards and potential publications if those exist. All the other detailed information about devices, instruments, acquisition procedures, we capture all this information in a text file, in a README to make it available over there. And then we have links to the data sets as well. So this is basically the way to capture the data. Then our main goal is to basically makes those data as broadly available as possible. So you can search it on our portal. That's one option. So we have a search page where you can search or filter by different free text terms that will look through the keywords, abstract, title of the data descriptions, but you can also select by award, by certain data provider, person, specific programs. And we do also have a map-based option here where you we describe all the different data sets and projects on a map. So each of those is indicated by a central point. And if you click on a point, you actually get a box that shows the full extent of the data set, because many of the data sets we have extend for large areas. If we just show the full extent of everything, then it will be too confusing on the map. The map also has the option to narrow down the search further by selecting a rectangle or a polygon where you can, carve out certain areas, and will give you all the data sets we have for that specific area. And below the map, there will be like a table which actually shows all the different data sets. In addition to showing or to enable search in our portal itself, we try to increase the exposure. So we provide entries to the Antarctic metadata directory we create DOIs that can be searched via data site. We also expose our data through data one, and all the dataset pages have the schema.org information, as we heard like earlier. So they can also be found through the folder search option that was described earlier.
1 minute left.
Thank
Frank.
you. We also have an API that allows machine access to our metadata catalog, where people can programmatically extract information from there. So their goal is to increase discovery and reuse. And so that's basically what I have to say. The main question we have is like sometimes in the descriptions, we really rely on the data providers to provide a really good complete set of metadata. So we hope in the future maybe to quantify this a little better and maybe give a little like fair score to the different data sets. But because we get data from all kinds of different disciplines, it's sometimes really difficult to know for us like what are the appropriate metadata for the specific discipline. So please check it out or contact us if you have any questions, and I'm also happy to answer questions in the chat or in the discussion.
Thank you very much, Frank, for your presentation. Are there any questions for Frank? If not, okay, I just have one quick one because we are running a little bit behind. Do you have also prescriptive data formats that you allow, or are you like?
We are pretty open. We are pretty open in the data formats. We try to encourage like free, open, non-proprietary format. So we, encourage CSV, NetCDF, JPEG or TIFF formats. We do accept, for example, like Excel data still, because a lot of data, I think a lot of communities, they just have like a simple Excel table, and I think people are used to use it. Also, we encourage, and we might do it more in the future, to have all those data as a CSV file.
Okay, thank you for the clarification. Just a brief reminder that we also have one poster on data sharing from Masaki Kanao about data and metadata management for Antarctic sciences at the National Antarctic Data Center in Japan. So please have a look at the poster in the platform. And I would now like to once again invite all panelists to join a short discussion on data sharing. I don't think we have any questions from the audience, so we can move on to the panel discussion. So to promote the discussion, maybe I can start with the first question. If anybody would like to comment, what are the main obstacles in fair data sharing in your view?
I mean, I think one of the things that I've seen is the increased burden on the data managers that they have to continue to manage when the funding is parceled out, bit by bit, and that becomes even more complex when we try to add the expectations of what people can do now is increasing, and so if we look at the horizon and there's a new push to adopt a digital object framework, which is going to put a whole nother level of management and expectations for the data managers and how they expose data and how they can make that data machine actionable and interoperable with other platforms. So I think that's the biggest challenge, is the increased expectation with the piecemeal funding together is a bad combination.
Still, I completely agree. That's one of the very challenging aspects. Anybody else?
As a data manager, I concur with that as well. I don't have anything to add, but I definitely agree.
Yeah, I think we're getting the findable and maybe accessibility aspects. We're getting a better grips on it, as with the Pull Initiative and others, and some like schema.org basic metadata standard. But the interoperability, that's as I said, because that requires kind of data format standards for the data itself, if it's done machine readable. So that's, I think it's going to be tricky, and that I think we need to work with the different discipline communities to make that happen.
Yeah, I think it also needs a change of the culture a little bit, so that the community gets used to using terminologies more, that we can validate, and that they can become part of the machine readability and support the interoperability of the data. Any other thoughts?
One question just came into the Q&A from Monica Mulbert. Have you considered the fact that there are still places where there is no dedicated data manager?
Do you mean not in a specific, there is not dedicated data center for the data? Not quite sure.
I don't know. I mean, if we can allow Monica to speak if she wants to also clarify that.
Hi. Hello, everyone. Thank you very much for the opportunity. I guess I mean both. No dedicated data center, but also no dedicated data manager. What I'm trying to get at is that there is a big disparity on data management structure across the world and across Antarctic communities and programs. So maybe one thing to consider is how we can improve inclusiveness and make whatever tools we are developing accessible to everyone. Thank you.
This is a very good point. And so for the US, I mean, that's for one, I mean, that's the reason that USUBDC exists in the US, because we wanted to have one data center that's for all the US data, but it doesn't solve necessarily the problem for other countries. But there's also the this SCA Standing Committee on Antarctic Data Managers, SCADAM, which is, I think, one of their goal is to help other countries to build up capacity and, do help with resources. And I think in the last couple of years, we have worked with Switzerland and Turkey, India, and other countries to kind of share information, help them to build the capacity. And also, if some countries might not have that, they can contact like SCADAM, and then we can direct them to maybe data centers that can help out there as well.
I think similar holds for the SUS data management subcommittee that can act also as a broker between the scientists and the most appropriate repository that could accommodate the data. And perhaps also some of the products like the one that Yiming today was talking about, like the SCAR Antarctic Biodiversity Portal, is actually not a really national resource. So anybody who has that type of data would be able to use that. So perhaps that's also one way of promoting sharing data independent of nationality and national programs.
Exactly.
Can I add one thing to that as well? So where we can't enforce standards, we can at least nudge our collaborators and users to use the correct standards, right? That's kind of what we're doing with the repository. You can't submit data unless you have a certain amount of documentation. We provide a number of samples and examples for folks to kind of have a model when they're preparing their data for long-term storage. So yeah, I just think that like a small psychological nudge to say, hey, this is how others are doing it, is enough to kind of make people mindful of these standards.
I think that in case of marine data, we have very few vessels operating in Antarctic water. So one way could be coordinate the metadata or the way to work between vessels, because we need to share the data between vessels in any case. And if we do the job on board, we have done lots of work. In any case, researcher on board, when find a standard, normally try to follow that standard. So you have lots of work done in this sense. I don't know if okay, only this.
Thank you. Thank you for your thoughts. Any other ideas or views? We have 3 minutes till the end of the workshop. So I would like to thank very much all speakers and poster creators for their inspiring presentations and panel discussions that hopefully planted some seeds of new ideas and collaborations. I also would like to mention that if you like to engage with SCADAM or the SUS Data Management Subcommittee, you can have a look at our respective websites, and we would be happy to follow up with your questions and comments. Taco and Frank, do you have anything you would like to add at this point?
No, just echoing your words that very inspiring presentations, and I hope that we will get some cooperation between some of the projects that were mentioned and some of the initiatives that were mentioned. So yeah, thank you very much.
Yeah, thank you, Petra. And also, as I said earlier, SCADAM is open for everybody to ask questions and to join. We have like monthly talks, meetings, and there's also, as I was mentioned earlier by Karen, like there's for the polder community to share data. There's like, I think, more or less regular hackathon that's also free and open. So if you go to the polder, if you search for polder on website, then I think you find probably links to that, where there's all ongoing discussions about metadata, making data more findable and things. So there's opportunities to engage for people who want to. learn more about this.
Okay. Thank you. So at the end, I would just also like to thank my colleague conveners, Taco and Frank, for all their effort in co-organizing this workshop. And thank you all in the audience for your time and attention. Thank you. Bye-bye.
Thank you.
Thank you.
Thank you. Bye-bye.
Thank you very much. Bye.
Petra, do you need anything from me, or have you got slides, or?
I think that's fine because everything will be recorded, so we should be able to access it via the YouTube channel.
Let me know. Thanks for
Thank
doing
you
that.
very much for participating.
Bye.
All right. Very good job, Petra. That was really good getting through.
IT team, thank you so much.
Thank you very much for your support,
Yeah.
Star IT team.